Very nice. So let's go back and make sure we understand. F2 divided by that area is sigma yx. F1 divided by this area is sigma xy. Because of moments, those two things have to be equal. If I take moments around the center, you can see that those two things have to be equal. So that means that sigma xy and sigma yx have to be the same. That's what moment equilibrium tells us. That means we can further simplify our stress expressions. Sigma nn equal to sigma xx cos squared theta plus sigma yy sin squared theta plus, instead of having sigma xy and sigma yx, I can write 2 sigma xy sin theta cos theta. Sigma nt. So this is normal stress. This is shear stress. Equals minus sigma xx plus sigma yy sin theta cos theta plus sigma xy cos squared theta minus sin squared theta. We're done. Let's look at an example to make sure that we know how to do this. Okay. So I'm going to do a worked example from the text. Okay, what is given to us? So because we want to make sure we understand this, right? Example. So here it is. So I got this thing. Okay, and it says 25 MPa. Compression, so 76.5 MPa. 32 MPa. And it doesn't say anything here. So you are supposed to find out, and then it just, the rest of the stuff we don't really care, you know what I mean? Because this side will be 32 MPa by equilibrium. This side will be 76.5 MPa. This side will be 25, 25, 25. Notice how it is drawn, right? These two arrows come together. These two arrows come together. So we are going to figure out theta equal to 50 degrees. So at theta equal to 50 degrees from x-axis. That means that I am looking at something that is, the face is like this. This angle is 50 degrees. That means normal is like this, right? So now we set. So I'm going to do this problem. You will see what I mean. Okay. So I'm going to do this by using, of course, Excel, because it's easy for me to show you the numbers. So sigma. So I'm going to write Sxx given to us minus 76.5. So for you to be able to see, I'm going to zoom it a little bit. There. So you can see it a little bit better, right? SYY, tell me what it is. Is it obvious to you? It's minus 32 megapascals. Compression is negative, tension is positive. We did this even in our 221 class, you know, statics and dynamics, so you should be aware of that. Then tau xy. So I'll write it as Sxy is 25 MPa. And then angle theta. So now, if you want to find this thing, first I have to draw the nose. So x-axis is here. The nose is like this. So the angle that the nose makes with the x-axis is this much, negative 40 degrees. Can you see if this angle is 50 degrees, that is negative 40 degrees. So I'm going to go up here and I'm going to say theta equals, I'm going to write it in radians, minus 40 times pi over 108. This is radians. Now we are ready. SNN equals, or massive formula, it is SXX times cos of this squared plus SXY, sorry, SYY plus this times sine of this square plus 2 times SXY times cos of this times sine of this. That's it. Enter. SNN is minus 82 megapascals. SNT equals minus SXX times sine. Let's check, make sure that we are getting the right one. After this is just plugging in the formula, sine theta cos theta, right? So plus so we're going to do this in a different way. It is SYY minus SXX times sine theta times cos theta plus SXY times cos, so I'm going to write a star here, cos theta whole squared minus sine theta whole squared So what will this look like? Let's draw this so that you can see. So I'm going to draw a rectangle like this. Sorry, it was the other way, right? I'm going to erase this. The rectangle was like this, and we are looking at this face. That's the face. And our SNN was like that, 82.7 MPa. And then SNT, remember our directions, right? It always goes that way, which means that SNT being negative means it is pointing that way. So what we are going to do is we're going to write that like that and write 17.5. The nice thing is, if you want to find out what's happening on this face, you only have to recompute SNN, because SNT will still be 17.5 and this is going against, that will go like that, 17.5, okay? So you can already fill in this guide, 17.5. 17.5. So what will be this angle? If this is normal, how much is this? Play around with it and you should see that this angle is 50 degrees. So if you want to compute on this face, you have to, on this face, you have to use this angle. Got it? Very good. So I hope you got the idea. The main thing is to make sure, so let me say this again and again and again, because this is the most important thing. Get the normal correct. Theta is measured CCW from positive x-axis. So you have to make sure you draw your axis and your normal, okay? Then theta is measured counterclockwise, positive from x-axis. This is the main decision you have to make. Substituting cos squared theta, sin squared theta,